Everyone, welcome to the solutions video for Selective Prep Mathematics, test number 38. We'll just get started into our overview straight away. So a lot of the questions that we'll be looking at in this solution video or in this exam paper will involve patterns or like sequences. So sequences are just a number of or a variety of numbers that are either in a pattern or that we want to add up. And so when we see this sequence or this line of numbers, and you can see them in the examples as well, that's exactly what I'm talking about. You want to try and find a pattern if possible. Okay, so whether it's a sequence or it's an addition sequence, okay, then you want to try and find a pattern, and that'll make things a lot quicker than trying to, let's say, add them up one by one, or just try and figure out the blank without knowing a pattern. If there's no obvious pattern, then try and like, let's say it's an addition sequence, then the best tip to use is that you want to try and make pairs to save time. And I'll tell you exactly what I'm talking about in about one or two examples, but let's take a look at a couple different examples first. So the first example is a pretty common pattern that's used in exams. It's called the Fibonacci pattern or Fibonacci sequence. Okay, it's just basically you're adding two numbers to get the next number. And so you have 1 plus 2 gives you 3, 2 plus 3 gives you 5, 3 plus 5 gives you 8, so on, so on, so on. And if you were to try and find the blank, it would be 13 plus 21, so it'd be 34. Okay. Now for the second term, they're asking us to find the 20th term. Sorry, for the second sequence, they're asking us to find the 20th term, and we know that the first term is 3. Again, what you want to do is you want to label what term they are. So term number 1, term number 2, term number 3, and then try and find a relationship between the term and the actual number. Okay, so what term it is, and then the actual number that the first or second term is. And so the term I'm going to call n, so n can be 1, 2, 3, 4, 5, and the actual number I'm going to call x. So x is 3, 5, 7, 9, 11, so on, so on, so on. And I want to try to find an equation between n and x. In this case, x is going to be 2n plus 1. Okay, so when n equals 1 for the first term, okay, x is going to be 3. When n is 2, it's going to be 2n, so 4 plus 1 equals 5, so on, so on, so on, so on. And when we're trying to find the 20th term, this really helps because we don't need to find like the 10th, 11th, 12th, and build up all the way to try and find the 20th term. We just need to sub in n equals 20 in, and that should give us 2 times 20 plus 1, which is 41. Okay, so 41 should be our 20th term. Now, when we have an addition sequence, we can try and find a pattern. Okay, if we want, here it would be x equals 2n minus 1. Okay, we can do that, but in this case, it doesn't really help us because we're trying to add stuff up. So if we can, we want to try and find a pattern for the addition sequence. So when we're adding just the first one up, we have 1. Okay, we can't really work with that too much. It could be just x or x squared, x cubed, whatever. Could be 2x minus 1 or 0x plus 1, could be anything. So let's take a look at adding the first two numbers together. So adding the first one only was 1, adding the first 2 is 4, adding the first 3 is 9, adding the first 4 is 16. Okay, so you can see these are all square numbers. So I'm going to use the term sigma. This just means add, okay, n. So adding n terms together equals x squared. Sorry, equals n squared. Okay, so adding the first two terms is going to be 2 squared, adding the first 3 terms is 3 squared, adding the first 4 terms is 4 squared, etc., etc. So what is the sum of the sequence? Now, adding, so how many terms do we have? So we have 1, 2, up to 49, and so if we were to have started at 2, if we had gone 2, 4, 6, blah, 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 and we had gone all the way to 50, which is the same number of terms as this, we would have had 25 terms. So 25 terms here, so n equals 25, so if I do n squared, it's going to be 625. Okay, so that's the sum of the sequence. So you want to try and find these patterns if possible. So calculating averages for algebra, we've gone through this quite a few times. If you haven't seen those previous videos, okay, I'll just have a quick, I'll explain this quickly. Basically, all we want to do when we're calculating averages is understand and remember this one formula here. So it's just the sum of all the scores over the total number of scores. So you want to add up the score that every single person got over the total number of people there are, or the total number of scores there are if it's not people. Percentages, pretty much, we've gone through this a bunch of times as well. Save time. Calculate the final percentage. Don't try and calculate what each percentage is one by one. So don't be like, oh, 40% is 40, 60% is 60, add them together. No, just do 40 plus 60 equals 100. If you're 100% of 100 is $100, and so $100 is the final, or something like that. If you want to take a read through the example, then pause the video and do that. So we'll get started with the questions straight away. We have a book that's numbered 1, 2, 3, so on, so on, so on, two-digit pages, three-digit pages, and we'll try and figure out how many of those there are. So for one-digit pages, there's 1 to 9. Okay, so there's 9 one-digit pages. Now for two-digit pages, there's 10 to 19, so that's 10 terms. We're splitting it into groups of 10 to make this easier to calculate. 20 to 29, all the way to 90 to 99. That's 9 groups. So 9 groups of 10, which have 2 digits. So that's 180. So now that we have 1 digit and 2 digits covered, let's try and figure out how many 3-digit numbers we can make to figure out which number this finishes on. This book finishes on. So 852. Let's do some subtraction to see how many digits we can use up. So 3, 6, 6. So 663 digits. If we divide that by 3 to see how many 3-digit numbers we can make, it's going to be 221. So we can make 221 3-digit numbers after 99. So the first one's going to be 100, and then 220 more later is going to be 320. Angles. So basically, angles on a straight line equal 180 degrees. Okay, so this is going to be 95, 100, 80. And so if you calculate, this is going to be 85. Because angles in a quadrilateral add up to 360 degrees. And so using our straight line theorem again, angles on a straight line equal 180, this x should equal 95 degrees. Question 3, sequences. So this is actually the same sequence we saw in our example. So 1 plus 3 plus 5 plus 7 plus blah, 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 blah. Okay, we can't really pair up here. It's a bit difficult to pair up. So what we're going to do is we are going to find the pattern. And we found the pattern here before was that n squared is the sum of however many terms we're adding up. And so if we're taking a look at 1 plus itself, or well, just 1 on its own, the first term, the sum is going to be 1. 1 plus 3 is going to be 4. So since we've added the first 2 terms together, 2 squared is 4. 1 plus 3 plus 5 is 9. Because we added the first 3 terms together, the sum is 9. Okay, or 3 squared. And so we want to see how many have we added up here? Well, the sum is 625. So what squared equals 625? 25 squared equals 625. And if we're starting at 1 and counting up odd numbers, okay, 25 terms, the 25th odd number is going to be 49. Okay, if you had thought about it as 2 plus 4 plus 6 plus 8, okay, the 25th even number would have been 50. So it's going to be 1 less than that, right? Because the odd numbers are all 1 less. Now, question 4, we have an averages question, so it should have just been 75% times 10 plus 5 times 60% plus 15 times 52%. If you had done the maths for that, it would have given you 61%. Oh, sorry, it should have all been over 10 plus 5 plus 15. 10 plus 5 plus 15, which equals 30. So these over 30 should have given you 61%. So for this question, you should have first noticed that it's a square. What the shapes on both sides are squares. That's what they say. And so the sides are all equal. And so this is an equilateral triangle, which means that the bottom 2 angles are equal to each other. Now, every single angle of a square is 90 degrees. And so what's left over here, because angles around a point equal 360 degrees, we have 120 plus 90 plus 90, which is 300. So leftover needs to be 60 degrees. Now, angle sum of a triangle is 180 degrees. And so the leftover 2 base angles, which are equal, should add up to 120 degrees. And so if they're both equal and add up to 120, they should be 60 and 60. Question 6, we have side A, which is 4 by 10, and then side B, which is 25 by 4, which means that we have two sides that are 4 by 10, two sides that are 4 by 25, and then two sides that are 10 by 25. So that's top and bottom. And so when we add those all up, we should get 780. So that's 80, that's 200, and that's 500. Now, we have John and we have David. John runs at 5 kilometers per hour, or 5,000 meters per 60 minutes. Okay, David at 3,000 meters per 60 minutes. Now, how long does it take each one to run 1 kilometer? So 1/5 for John, 1/5 of an hour. So 1 kilometer per 12 minutes. For David, it would be 1 kilometer, so 1/3 of an hour, so 20 minutes. So if David's given a 5-minute head start, he will finish in 15 minutes, which means that John will still finish 3 minutes ahead of him. This question is not too hard. We have 8 triangles that are equal in size. Okay, 3 of them are shaded in, so it should have been 3 out of 8. So percentages, we have 132,600 tons of fruit, and 1% of that is going to be 1,326 tons. So 1326, and how much is apples? 52%. So we're going to try and multiply by 52. Okay, some quick multiplication should give you 2, 1, 5, 6, 2. 5 times 6 is 30. Just carry the 3 over. 5 times 2 is 10, plus 3 is 13. 5 times 3 plus 1 is 16. 1. So 6630 should give you 68952. So part C. So question 10, it's the same thing. We have 1% equals 1326, but we're multiplying by oranges and plus pears. So we don't want to do oranges and pears separately. Add them together first. So that's 23% altogether. And when we multiply them, you should get 8, 7, 9, 3, 12, 5, 6. You can pause and double check this if you want. Okay, if you think something's wrong, double check it. I believe there shouldn't be anything wrong. So part B. Okay. And now we have a trapezium and a circle. Basically, we're trying to find the area of this trapezium and just this outer semicircle here, because this inner semicircle is already part of the trapezium. So area of a trapezium equals h over 2a plus b, where a plus b is just the longer side and the shorter side. So that should give you 4 on 2, and then 10 plus 6, which will be, 10 plus 6, which should give you 16 times 2, which is 32. And then the area of the semicircle, SC stands for semicircle, should be half, because we've got half a circle, times pi r squared. So pi is 3.14, and then r squared should be 2, because diameter is 4, so 2 squared. So 2 squared, so 4 times 3.14 is 12.56, times half equals 6.28. So 6.28 plus 32 gives you 38.28. Now, final question, we have a staircase. So we have n equals 1, first row, n equals 2, n equals 3, n equals 4. And in each row, or each n, or each term, we just go up by 1. So the number of blocks in each row or each term is the same as the term itself. So 1 plus 2 plus 3 plus 4 plus, and we want to see how many we have, or how many blocks we have if the staircase extends till 15 units tall. So plus 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 all the way till 15. And then plus 15. And what we want to do here is we want to pair up. Okay, there's no significant pattern here to find. We just want to pair up. But there's an odd number of terms. So if you're trying to pair up, you need to make this even. So let's forget about the 15 for now. Okay, and let's just pair up either end. So 2 and 13, 3 and 12, 4 and 11. So this is all just pairs of 15. This pairing up gives you the same, adds up to the same number, and it gives you a certain pair, a number of pairs. So here we have 7 pairs, because we have 1 to 14. So 7 pairs of 15, but we got to add our last 15 as well. We can't just forget about it. Okay, so plus 15 equals 8 times 15, which gives you 120. Okay, so that was the last question. Just a couple of key takeaways from this test. was sequencing. So find a pattern or just try and pair up if it's an addition sequence. With averages, use the same formula every time. Don't get confused. Okay, don't try and use something else. It's just a waste of time. And for percentages, find the final percentage only. Don't waste your time trying to find individual values or what the value of each different percentage. Okay, just the final value. That's it. Save your time. All right, good job today, guys. That was a pretty intense solutions video, but good job for keeping up. I will see you in the next video.